Hi guys, welcome back. In the previous lectures, we have implemented and tested the HTTP APIs to manage bank accounts for our Simple Bank project. Today we will do some more practice by implementing the most important API for our application, Transfer Money API. And while doing so, I will show you how to write a custom validator to validate the input parameters of this API. Okay, let's open the terminal and go to the Simple Bank project folder. Then open it with Visual Studio Code. First, I will create a new transfer.go file inside the API package. The implementation of the Transfer Money API will be very similar to that of the Create Account API. So I'm going to copy this block of code from the account.go file and paste it to the transfer.go file. The struct to store input parameters of this API should be transfer request. It will have several fields. The from account ID of type int64 is the ID of the account where money is going out. This field is required and its minimum value should be 1. Similarly, the toAccount ID, also of type int64, is the ID of the account where money is going in. Next, we have the amount field to store the amount of money to transfer between two accounts. For simplicity, here we just use integer type. But in reality, it could be a real number, depending on the currency. So you should keep that in mind and choose the appropriate type for your data. Now for the binding condition, this field is also required. And although this minimum value of 1 is correct, since we are using integer type for the money, it's better to say the amount of transferring money should be greater than 0. So that later, if we want to support real number, such as $0.5, it will still be valid. The last field is the currency of the money we want to transfer. For now, we only allow it to be either USD, Euro, or CAD. And note that this currency should match the currency of both two accounts. We will verify that in the API handler function. Alright, now the handler function's name should be changed to create transfer. And this request variable's type should be transfer request. We bind the input parameters to the request object and return back request status to the client if any of the parameters is invalid. Next, we have to create a transfer.txt param object, where from account ID is request.fromAccount ID, toAccount ID is request.toAccount ID, and amount is request.amount. Okay, now with this argument, we call server.store.transfer.txt to perform the money transfer transaction. This function will return a transfer.txt result object or an error. So I'm going to change this variable to result. And at the end, we just need to return that result to the client if no errors occur. Alright, this create transfer handler is almost finished, except that we haven't taken into account the last input parameter, currency. What we need to do is to compare this currency with the currency of the from account and to account to make sure that they're all the same. So I'm going to define a new function called validaccount for the server struct. This function will check if an account with a specific ID really exists and its currency matches the input currency. Therefore, it will have 3 input arguments: a gin.context, an account ID, and a currency string. And it will return a bool value. First, we call server.store.getAccount to query the account from the database. This function will return an account object or an error. If error is not nil, then there are 2 possible scenarios, just like what we have handled in the getAccount API handler. So let's copy this chunk of code and paste it here. The first scenario is when the account doesn't exist. Then we return status not found to the client. The second scenario is when some unexpected errors occur, so we just return status internal server error. Otherwise, if there's no errors, we will check if the account's currency matches with the input currency or not. If it doesn't match, we declare a new error, account currency mismatch. Here I put all the account ID, account currency, and input currency in this error message to make it easier to understand for the client. Then we call context.json with a status batch request to send this error response to the client and return false. We also have to return false for the 2 error cases above. Finally, if everything is good and the account is valid, we return true at the end of this function. Now let's go back to the create transfer handler. We call server.validAccount to check the validity of the request.fromAccountID and currency. If it's not valid, then we just return immediately. We do the same thing for the request.toAccountID. And that's it. The create transfer handler is completed. Next, we have to register a new API in the server to route requests to this handler. So let's open the server.go file. I'm gonna duplicate this router.postaccount API. Change the path to /transfers. And this handler's name to server.createTransfer. That's all. Let's open the terminal and run make server. Then I'm gonna use Postman to test the new transfer money API. Let's copy this URL from the create account API request. Then create a new tab, select method post, and paste in the URL. We have to change this route to transfers. Now for the request body, let's select raw and choose JSON format. I'm gonna add a sample JSON body here. The from account ID is 1, the to account ID is 2, the amount is 10, and the currency is USD. Okay, let's open Table Plus to see the current data for these 2 accounts. Here we can see that their currencies are different. The currency of account 2 is USD, but that of account 1 is CAD. So if we send this API request, we'll get a currency mismatch error for the account 1. To fix this, I will update the currency of account 1 to USD. Save it and go back to Postman to send the request again. This time the request is successful, and in the response we have a transfer record with ID 110 from account 1 to account 2 with amount of 10. This is a from account data after performing the transfer. Its new balance is 734 USD, and this is a to account with 824 USD. Let's check the database record in Table Plus. Here are the original values of account 1 and account 2 before the transaction. 744 and 814 USD. When I press Command R to refresh the data, we can see that the balance of account 1 has decreased by 10 and the balance of account 2 has increased by 10. Moreover, in the response, we also see 2 account entry objects. One entry is to record that 10 USD has been subtracted from account 1. And the other entry is to record that 10 USD has been added to account 2. We can find these 2 records at the end of the entries table in the database. Similar for the transfer record at the bottom of the transfers table, which matches the transfer object returned in the JSON response. Alright, so the transfer API works perfectly. But there's one thing I want to show you. Here in the binding condition of the currency field, we are hardcoding 3 constants for USD, Euro, and CAD. What if in the future we want to support 100 different types of currency? It will be very hard to read and easy to make mistakes if you put 100 currency values in this one-off tag. Also, there will be duplications because the currency parameter can appear in many different APIs. For now, we already have one duplication in the create account request. In order to avoid that, I'm going to show you how to write a custom validator for the currency field. Let's create a new file, validator.go, inside the API folder. Then declare a new variable, valid currency, of type validator.function. Visual Studio Code has automatically imported the validator package for us. However, we have to add /v10 at the end of this import path because we want to use the version 10 of this package. Now let's open this function definition to see its signature. Basically, it's a function that takes a field level interface as input and returns true when validation succeeds. So let's copy it to our custom currency validator. I'm going to change this variable's name to field level, and its type should be validator.fieldLevel. This is an interface that contains all information and helper functions to validate a field. Now what we need to do is calling fieldLevel.field to get the value of the field. Note that it's a reflection value, so we have to call .interface to get its value as an empty interface. Then we try to convert this value to a string. The conversion will return a currency string and an OK boolean value. If OK is true, then the currency is a valid string. In this case, we will have to check if that currency is supported or not. Else, if OK is false, then the field is not a string. Therefore, we just return false. Alright, now I will create a new file, currency.go, inside the util package. We will implement the logic to check if a currency is supported or not in this file. First, I will declare some constants for the currencies that we want to support in our bank. For now, let's say we only support USD, Euro, and CAD. We can easily add more currencies in the future if we want. Then let's write a function, isSupportedCurrency, that takes a currency string as input and return a bool value. It will return true if the input currency is supported and false otherwise. In this function, we just use a simple switch case statement. In case the currency is USD, Euro, or CAD, we return true. Else, we return false. And that's it. Now go back to the valid currency validator. Here we simply return util.isSupportedCurrency and pass in the input currency. And the validator is done. Next, we have to register this custom validator with Gene. So let's open the server.go file. Here, after creating the Gene router, we call binding.validator.engine to get the current validator engine that Gene is using. Binding is a subpackage of Gene. And note that this function will return a general interface type, which by default is a pointer to the validator object of the Go Playground validator package. So here we have to convert the output to a validator.validate pointer. If it is OK, then we can call v.registerValidation to register our custom validate function. The first argument is the name of the validation tag, let's say currency, and the second argument should be the valid currency function that we have implemented before. We got a syntax error because the package we're importing is not correct. It should be validator version 10. Alright, now with this new validator registered, we can start using it. Here in the create account request struct, we can replace this one-off tag with just currency. And similar for this currency field of the transfer request struct. Okay, let's restart the server and test it. I'm going to change the currency to Euro and send the request. This is a valid supported currency, but it doesn't match the currency of the account. So we've got a 400 bad request status with the currency mismatch error. If I change it back to USD, then the request is successful again. Now let's try an unsupported currency, such as AUD. This time we also get a 400 bad request status, but the error is because the field validation for currency failed on the currency tag, which is exactly what we expected. So our custom currency validator is working very well. Before we finish, I will update the random currency function to use the currency constant that we've declared before. And we're done. So today we have learned how to implement the transfer money API with the custom parameter binding validator. I hope it is useful for you. Although I didn't show you how to write unit tests for this new API in the video, because it will be very similar to what we've learned in the previous lecture. I actually write a lot of unit tests for it and push them to GitHub. I encourage you to check them out on the SimpleBank repository to see how they were implemented. Thanks a lot for watching this video, and I will see you soon in the next one.